In this lecture, we'll talk a little bit more about variables. Variables are key. Variables, just like in algebra, you need variables to write code. And we'll talk about variables and how they can be defined and what they mean. So variables, they're basically names that represent values in a program. Similar to algebraic variables. So just like in algebra, x equals 5, right? X equals y plus 2. You have these variables, x, y. They're names that are substitutes for certain values. All variables have a type, which must be declared. So type is an important concept in C and in most languages. The type of a variable tells you, basically intuitively, it tells you what kind of data it is going to hold. So for instance here, I say int x. I'm saying x is going to be an integer. Int is short for integer. Or I say float y. I'm saying y is going to be a floating point number. So I'm telling you what type of information is going to be held in that variable. Now the type is important because it determines how arithmetic is performed, and it determines how much memory is going to be used to store the variable. Because remember, all these variables have to be stored in memory somewhere, right? And so the question is, with a variable like x, how many bytes of space do we need to store that information? And with y, how many bytes of information? Because the machine, when it's running, it has to store it, it has to know how big it's going to be. So that's what the declarations are for. If you say int x, you know, oh, x is going to be the size of an integer, whatever that is on your machine. Like standard 32-bit machine, an integer is going to be 4 bytes. Depends on the processor, but 4 bytes is standard for a 32-bit machine. Floating point might be 8 bytes, something like that, or I can't remember, maybe 8, maybe 4, maybe 8. But there are fixed sizes depending on the machine for each type. So one thing that type lets you know is how much memory is going to be needed. But also, the type tells you how arithmetic will be performed. So arithmetic is performed differently depending on the type of data. So integer. If you have an integer type and you want to do addition, everybody knows how to do integer addition. But floating point addition is a much more complicated thing. So if you want to do floating point addition, you use, actually what happens inside the hardware, inside the microprocessor, is there's often a floating point unit, a dedicated piece of hardware just there to do floating point operations. And it is separate than the integer operators. So you'll have an integer ALU, arithmetic logic unit, which performs integer addition. And then you'll have some floating point unit that does floating point operations. And so depending on the type, you're going to have to send that data to a different piece of hardware to do the operations that need to be performed. Or like floating point division is a whole other thing. You have a special floating point divider unit, which is definitely different than, say, an integer divide. So that's why typing is needed. You need to know what type all the variables are going to be. And so in C, you have to declare the type. So before you use a variable, you have to declare it. So before you can use x in your program, you have to say int x semicolon somewhere, or float y semicolon, something like that. So that's what variables are. You've got to declare them in C. Now, the types, so there are several built-in types. Here are the main ones we're going to look at: char, int, float, and double. Really, we're going to focus on probably char and int. When it comes to embedded systems, we try to avoid floats and doubles because floating point arithmetic and double is double precision floating point, is slower and bigger. So we try to avoid them in general. Sometimes you need them, but try to avoid them. So an int is typically whatever the word size is, but it could be down to 16. So for instance, with an Arduino, I believe an int is 16 bits. But a char, no matter what platform you're using, a char is always 1 byte. That's just a standard size, right? So actually it's very useful. It's nice when I'm coding, you use a char and you always know what you're going to get, right? So I often use a char by default. But floating point and double, they can be 64 bits, 128. They can be much longer. Now variables all have names. They have to have names associated with them. It's just a sequence of visible characters. There are some limits. For instance, it has to start with a non-numerical character. So you can have int testvar1, that's legal because it starts with a T. But you can't have int 1 testvar because it starts with a 1, right? So that's not legal. You can't have any variable names that are C keywords, if, else, while, that sort of thing. So there are some limits on variable names, but you have wide discretion in what your name's going to be. Thank you.